Mic on. Hopefully, okay. Audio on. So, good morning, everybody. I'm going to pace myself this morning. What I should have been doing all along, which, morning, Brooksy. This sort of let everyone sort of say a good morning, so I'm going to pitch in. Except for my keyboard is frozen right now. I'm acting a little bit opposite of how I feel because I'm feeling a little bummed today, so I'm hoping that morning Dice K. I'm hoping that your group we can sort of cheer each other up. Because the lab we're doing today, at least for me, is the most fun one. Morning, Jack. Uh, Hopefully you find this lab to be satisfying. I don't know. I just think it's kind of fun. Um, so I'm gonna go look at the schedule real quick and show you where we're at, and then give you a chance to get set up if you need to. So we are on the week of April 28th. So we're doing lab 13 today. This has extra file in it, so you're going to download main.s. Macros.s is kind of like little functions we're going to create. So this will be your first introduction to creating some macros, which is a way to organize your code in assembly. And then the linker script. We don't actually need the open OCD file right now. In theory, never again, but definitely get main.s, macros.s, and the flash.ld file. I'm going to hide my browser for a second and just show you over here on mine. So I just downloaded everything. So I grabbed the diagram, the macros file, which is weird looking, but you'll see it's real easy to work with. Main.s, which we're used to looking at. I have this README because I went and found an answer to Vince's question from Tuesday. And then this is the OpenOCD file, and this is the Flash file. So I just downloaded everything to get ready, and then I created this README file because I put a note in there to myself to remind me to answer Vince's question. I'm going to wait and see if Vince turns up, which he's almost always here, and then I'll answer that question that was remaining from Tuesday. So anyway, if you don't have all the Lab 13 files, I just grabbed them all, but you really only need macros.s, main.s, and stm32 flash.ld. You need those three for sure. I just grabbed everything. That's the OpenOCD file. I grabbed it too, just to not have to think about it. And the diagram, which I didn't know Adam did this, so that's quite cool that Adam does that. Okay, so grab those files. In the short term, what I'm going to do to get set up and to sort of let us all get our brains warmed up, I'm going to go reconnect my circuit. So I still have this circuit because it's what we used on lab 11, and that didn't change. So if you took it apart, then you may have to go review this video again later and then double check your coding efforts. But if you didn't take it apart, then you may have what I have, which is a board disconnected, and the lab 11 circuit, which is the exact same circuit. So to start, I need to reconnect the breadboard to the Nucleo board. So that's where I'm going to start, and hopefully that'll give everyone a chance to get their brains warmed up a little bit while I do that. Okay, so I'm just going to start at this end for me. This is my ground wire. Can you see enough? Yeah, but you know where this is going. So this is my ground wire. I'm starting to remember where everybody lives. This is the far right one, so that goes to a D6. And then I'm just going to work my way from this end down toward the three-legged LED. That one will be last, so same as the diagram. So the second one over, I take it to D14, way up here. And I'm just being careful to sort of make sure I'm getting them in order, because the wires are kind of flopping around everywhere. Okay, here's the next one. That's the third one, D15. The fourth one goes to D8. See, the fifth one goes to D7. Now I'm on number 6 LED. So number 6 goes to 1, 2, 3. 6 goes to D11. The seventh one goes to D12. The eighth one goes to D13. Okay, so that's all the LED part. And then, sorry if you already wired this up and you're having to wait for me, but I thought it might give some people a chance to sort of get the juices flowing while I did this. And then I'm just I remember where these go. So PC10 is on this side of the board. So this side of the board. So there's all the LEDs. My ground is on this ground connector, and then PC10 is up here in the top left, depending on how you view it. So I'm going to take that first one. And this is getting to be a mess, but PC10. So PC10, just like before. We've done that. We've connected this before. See, it's up there. And then PC3 and PC2, I'm pretty sure if I remember correctly, are the bottom. I'm going to look at my card. Yeah, PC2 and PC3 are down here at the bottom. So if you can see it, but it's hard to see. There's PC2 and PC3, and then the ground wire, and then PC10 up here. And then I have the LEDs in all of the spots in the PA and PB various spots. So same circuit, I just connected it back up. And then I'm going to connect, I'm not going to power it just yet. I'm going to connect USB. On this side, okay, so that's my setup. And I'm going to start working in code. Okay, Vince is here. So good morning, Vince. I found an answer. So there was a question about why would we use U mul S. So why would we use U mul S? S mul S to set the negative and zero flags makes sense because signed multiplication can get a zero result or a negative result. But why would we use U mul S so that we get a negative or a zero flag? The zero flag makes sense because you can do unsigned multiplication and get zero. There is no reason, basically. But what negative does is it sets itself to the value of the 2 to the 63rd bit, which doesn't matter a whole lot with unsigned multiplication, but that's all it does. So I suppose someone might be able to use that piece of information with U mul S. But presumably it's because the circuit is designed to work that way, and even though it kind of is meaningless for U mol S, it's the same circuitry more or less for S mol S, so they just left it that way. So I wish that I had a way cooler answer, but that's the answer, is that it's not useful. But the information is there. Okay, so to get us warmed up a little bit, so we have a main.s, but we also have a macros.s, and macros is not exactly like a function, but more or less it's like a function in assembly. So if we look at macros.s as an example, which you can't see because I still have my browser showing. Okay. Oh, wait, here was my README that you never saw. So I made that note to myself and I left this as a file in my lab setup so that I would remember to tell you guys this answer. Okay, so in our lab this week we have a macros file and a main file. The macros is the name macros. That's just what we call this arrangement of assembly is macros. The name of the file could be anything you want it to be, so it could be apples.s or my helpers.s or utility.s. I just called it macros.s because inside of it are macros. I use the obvious name. It is assembly, that's what the .s tells us, but it's taking advantage of a feature of our assembler that allows you to create these macros, which are kind of like functions. They're not exactly like functions, but at least our first experience of them, and they're going to feel like void returning functions. So we're going to use these to organize our code like we would in any high-level language by putting the code for this different functionality in these macros. So the code to handle the delay, we're going to put that code inside of a delay macro, and then we will call the function or the macro in the main part of the program. So when we get there, the main will tell us, hey, head over to the macros file now and implement some macros. Okay, so that's going to come up here in just a bit. So this is the FizzBuzz program. What FizzBuzz does is, well, I'll do a quick example. What FizzBuzz does, so FizzBuzz, the way they usually present this problem is value, so loop from 1 to some n. Let's say 100. But anyway, you loop from 1 to some value n. And then as you're doing that, for each value as you're looping, if it's evenly divisible by 3, print fizz. If the value is else if evenly divisible by 5, print buzz. I'm going to say if, because I don't want that to be overly confusing. If evenly divisible by 3 and 5, print fizz buzz. If none of those things, print the value. So most of you have probably seen this problem somewhere. If you're unfamiliar with it, though, it's like a classic little test of a programmer's core capabilities, because this problem makes you write a loop, it makes you do decision making, and if else if, it makes you do some arithmetic. You have to increment a value, you have to test to see if values are evenly divisible, and it makes you do some outputs. So it's a classic little problem to sort of quickly assess if someone who calls themselves a programmer actually knows what they're doing at all. So we're going to do the assembly version of this. And since we don't have the ability to print the word fizz, print the word buzz, or print the word fizz buzz, what we're going to do is we're going to use our 3 color LED on our circuit. So if it should be fizz, we'll light up like PC2. If it should be buzz, we'll light up PC3, which would be a different color. And then if it's fizz buzz, we'll light up PC10, which will be the 3rd color on that 3-legged LED. So that's our fizz buzz part of our display. And then the none of those things means that we'll print the value out in binary, which we've already been doing in other labs. Although I'm going to rewrite the code today just so we can review it. So that's the problem that we're doing, and that's what the circuit is designed to show. So let me get main, and let's just start reading our way down. So this is the FizzBuzz program. It uses division and multiplication a little bit, so that's why we're doing it now, is because we just were introduced to division and multiplication. And then we also answered a couple of questions about how do I figure out if there's a remainder or not. Okay, so fortunately on this one, most of the work has been done for us. We don't have all of that pup DR and all that button related stuff because this circuit won't use a button. So we're just back to doing an output circuit. So we're going to do outputs possibly on A. So we're going to have to configure mode and then put data in output, mode for B and output, mode for C and output. So that's all been done. I'm just sort of quickly checking to make sure the numbers are right. This should be. This is boilerplate. We've had that before. So here's how you actually connect an external file into an assembly program, is with an include statement. Some of you may see the syntax highlighter get all goofy because of this line of code. I think I've probably fixed mine on my computer, but maybe not. I don't know. You can let me know if this is making your syntax highlighting look all goofy, and I can tell you what the quick fix is to that. Right now mine is not looking goofy, so I'm kind of fingers crossed that yours also looks okay. Now I did take an update for my language ARM plugin. Yeah, if you have an updated ARM plugin, update that, but also you have to remember to I'm going to put it in chat. So one quick fix is to comment it out. You just have to remember to comment it back in. So that's sort of the scary part, is you can comment it out, which is what I'll do since probably lots of you are seeing goofy syntax coloring. So I'm just reminding us all, you can comment this line out. Just make sure that we remember before we go compiling to undo that and comment it back in. Now, there is a fix. I took a plugin update recently, and I don't remember if that's what made this look nice again, or if I actually had fixed it myself at some point. So probably you'll be faster if you just comment that out, which is what I'm going to do, and we'll try to remember to comment it in. Ah, the update fixed it. Outstanding. Okay, so take the update. If you guys don't know it, down here at the bottom right corner, there will be a link down there showing that you have updates available if there are. So you might click and take that update. Okay, so let's hope that's true for everybody. Okay, so I'm just reading down. Like normal, I don't really have anything that I need to do until I see a numbered item. But I'm going to do this to kind of pace us, because some of you may be taking plugin updates. So there's the clock um, being enabled. That comment is actually wrong, because 7 is uh, this, is it not? Um, so it's actually the truth is that it's actually enabling GPIO-A, GPIO-B, and GPIO-C, which would be correct because we're doing outputs on all three of those. So the code was correct, the comment was wrong. Not that big a deal. Okay, so still no numbers. I'm just looking at it just to make sure that I know what's going on. So A, what it's doing is it is configuring the right pins, the correct pins for output mode. So this should be A5, A6, A7, A8, and A9 being configured for output. So that's that whole section. This whole section is configuring B8, B9, B10, and B6 for output. This section is configuring C2, C3, and C10 for output. All right, so now is something to sort of register in our brains. It's probably going to use the odd-even pattern that we've seen before. So the A output address is in R2. The B output address is in R4, and I'm sure I'm going to have to come back and look at this later again. And the C output is in R6. That's the memory bank addresses, right? R8. Okay, so R8 is the counter. So R8 is the FizzBuzz counter that goes from 1 up to something. It's telling me we're going to go from 1 to 100, so I'll be mindful of that. So R8 is the FizzBuzz counter. Okay, so still no numbered things here. This is just telling me what's happening. So here's the A output value being loaded, the appropriate bits being cleared and then stored back. Here's the B output value being loaded, the bits being cleared and stored back, and then here's the C output value being loaded. I don't think we needed to do that here, but anyway, we're getting a value and clearing some bits and then storing that back. So all that does is clear out the whole display every pass through the loop. Okay, here's number 1, FizzBuzz. So perform logic and call appropriate macros. So this is going to be a pain in our butt because to do R8 mod 15 equals 0, if you're familiar with FizzBuzz, by the way, you'll know that you have to check that it's evenly divisible by 3 and 5 first. But being evenly divisible by 3 and 5 at the same time is the same as being evenly divisible by 15. So it's telling me to set up a little tree. If evenly divisible by 15, we're going to call a macro. Else if evenly divisible by 3, call a macro. Else if evenly divisible by 5, call a macro. Else we call a different macro. So there's unfortunately math to do for that. Okay, so here's how we're going to go about this. Basically, all we're doing is we're going to divide R8 by 15, and then divide it by 3, and then divide it by 5. When you do division, you have to pick between signed and unsigned division. In this case, since R8 will only ever be between 1 and 100, so R8 is always unsigned, and the values we're dividing by are always unsigned, we can use unsigned division. So we can use udivs here. And we're going to be dividing. Let's see, we need to put this somewhere. Where do we want to put it? I guess we could put it anywhere, couldn't we? Am I going to have to show you this answer from the homework? No. Okay, here's what I'll do. I'll just go back to, what I'm going to do is just go do a quick refresh on how does udiv work. No, I don't actually, I'm pretty sure I have it memorized, but because you're new to it, let's go look at division and find the signature for udiv. All right, so udiv, we don't have a condition code, so we need a destination register, and then we're going to do something rn divided by something rm. So one thing I note here is that all of them have to be registers. All of them have to be registers as far as I can tell. So I need to just pick a destination. The rn part is r8, that's my counter, divided by some value. So let me now hide the browser again, and then you can just follow along with as I do this. So I'm just going to use R0 as my destination. I don't see that it's being used for anything anywhere. I'm going to divide R8 by something, but it told me that has to be in a register, so unfortunately I'm going to have to, let's just use R1. I'm going to have to put my dividing value into another register. So what I'm saying here is R0 equals R8 divided by R1. The reason why I used R1 here instead of 15 is because when I went and looked at the documentation, it told me that all three of these have to be a register. So what I had to do is get my value that I want to divide by, 15 in this case, into a register so that I could then pop off the division. Now this isn't the whole problem. If you remember from the homework, the whole problem is now presents itself because what we actually need is not how many times does R1 go into R8, but what's left afterward. So what we really need is, well, it's gonna, I'll write it out. What we really need is, it was the original total, right? So R8 minus R0 times R1. I don't know if you remember this. This was the total donuts minus the number of dozens times how many per dozen in my little donuts. Hold on, I got my foot caught. Okay. So that's that same math that we set up. R8 minus, so that was the total donuts minus how many dozens did dividing tell us we had times how many per dozen. So that's how this problem sort of lays itself out. And I'm just going to go straight to the chase because I'm just going to reuse R0 here. We have an instruction that does this, and it's a weird looking instruction because this part is placed here, and then this part is placed at the end. So that was the last problem on the homework, and it takes some getting used to, but what I've written here is R0 equals R8 minus R0 times R1. And what that gives me is R0 being the remainder of dividing R8 by R1. It looks really weird, but that's the assembly instructions to figure out. So at this point now I have R0, and that tells me if R0, and I can even say test equal, if R0 is 0, then it was evenly divisible by 15. So we're finally getting there. Let me separate this out a little bit. Hopefully that made some kind of sense. So our divisor first is 15. So the counter, which initially be 1, divided by 15. And then we get the remainder by whatever that's called, the dividend or what, the quotient. I don't remember. Anyway, Hopefully you remember from the donut example. That's how MLS is designed to work. There is a way to do a multiplication and then a subtraction to get this, but MLS is faster to code. Once we've done all that, so all of those three right there are entirely to set up the situation where we can figure out whether or not R8 was evenly divisible by 15. So if it was, then R0 will be 0. So we're going to set up an if-then block. Yeah, so if it is equal to 0, then it needs me to call. Yeah, I'm not super happy with that. Let's do it a different way. I've just had the feeling from experience that this might be easier if we use branching instead. So let's use a comparison instead. Let's compare R0 and 0. And we're going to use branching. So if it's not equal to R0, I'm going to make myself a label called try buzz. Now I'm going to put a label on this section that's not going to be useful for anything other than for us to remember what it was. So this is try fizz. Let me get this out of the way. I'll bring it back. Okay, so this label right here, I'm actually probably never going to branch to it, but it's helpful because it reminds me when I look at it. It doesn't hurt the code. It doesn't actually do anything, but it tells me that this whole section is trying. Nope, it's try fizzbuzz. So that would have been wrong. So I'm going to try fizzbuzz in this section, and if it fails, why am I not trying fizz next? I don't know. Okay, so now I have to, since I made it all confusing, I'll go back and describe what I'm doing. So I'm going to use labels in part because I can, just to sort of literally label the sections of code so I know what's going on where. So the first thing I'm going to try is the fizzbuzz part. So I'm going to load up 15 as my denominator for this R8 mod 15. But since there is no mod in ARM, I have to go through a two-step process to get the remainder. So after those two steps, I end up with R0 being the remainder. Then I do a comparison that tells me if the remainder was 0. If it's not 0, then it's not fizzbuzz, so I'm going to try lonely old fizz by itself. Now here you kind of have to remember how this works, but you're going to get practice here today at it. If it was equal, then this branch won't happen and the code will continue flowing. So in that case, I want to call the fizzbuzz macro, and you literally do that just by writing the name of the macro. So if I discovered that the remainder is not 0, then I get out of here and immediately go try fizz. But if it was equal to 0, then this branch won't happen, in which case I'll fire off the fizzbuzz macro. Let me just go show you the fizzbuzz macro. Here it is right here in macros.s. So there's the name fizzbuzz. That's how you call it. Just fizzbuzz. And the assembler will know to go fetch that code. We haven't written that code, but we're going to worry about that second. So hopefully that made some kind of sense. Now the other thing to be careful of is once I've done fizzbuzz, if I don't do otherwise, I'm also going to try fizz, and that's not what I want. So I need to do an unconditional branch to get out of here. Oh, there's an end tag, so I'll just jump to the end. Oh, I was close. End with the underscore on the other side. So that way, once I've done fizzbuzz, I don't try anything else. I'm going to end up by the way, trying um, buzz after that, and I'm going to end up at some point showing the value. So this is all the pieces of my tree. If fizz buzz, else if fizz, else if buzz, else show value. Um, so there's the whole fizz buzz section, the math, and then deciding whether or not it is fizz buzz. Otherwise, I need to get to trying fizz. But if it is fizz buzz, then I fire that off and then I get out of here. Hopefully that makes sense. Okay, so fizz. Now we have a pattern. Fizz is R8 mod 3 is 0, so I'm going to move into R1 the value 3 as my divisor. I'm going to unsigned divide. I'll use R0 again, R8 by R1. And now I can just sort of steal my pattern. So now I can say the remainder R0 equals the quotient R0 times the denominator, 3, and all of that subtracted from the original value should give me the remainder. So it's the same math sequence except for I changed the denominator for the mod. So at the end of this, R0 should have the remainder, at which point I can look and see, okay, is the remainder 0 when I tried to divide by 3? If it's not, then I should try buzz next. But if it is, then I will just fire off my fizz macro and then get out of here. Now, I personally think that this stuff looks pretty nice as far as assembly goes. Our particular assembler allows a fairly nice way of coding. I haven't compiled in a while, so we're taking huge chances here. Should we run the assembler? I'm going to. Let's take a chance and run the assembler. So I'm going to go back over here and just grab the first piece of the recipe. I'm just going to run the assembler step and see if I get any terrible errors. Okay, I did not. Hopefully you're not, but this will be a chance for us to clean up your errors if you're getting them. Notice, by the way, I did not compile macros.s because the include takes care of that. But I'm going to pause and make sure everyone's okay. I never commented in macros, but it's interesting that I didn't get any errors because of that. But I didn't, so what do you know? Um, but all right, that's good news. Hopefully I'm not the only one who forgot to comment back in the macros. Oh no, I had them comment. Okay, never mind. I didn't have them commented out, which is why I didn't get any errors. So hopefully you guys are all doing okay. Now we can move on to Buzz. So we know what this is going to look like. Buzz is mod 5, so load up 5, and then divide, same pattern. So I'll do the initial division into R0, R8 divided by R1. Um, and then I'll use MLS, so the remainder is the R0 times the R1, and that's subtracted from the original R8. Okay, hopefully that's not getting too low on the screen. Then we look to see if we got a remainder or not. Otherwise we call the buzz macro and then get out of here. The last one, by the way, on value, it just says call the value macro. So isn't that good news? Because that's all I'm going to do. And I don't need a branch at this point because the program will just naturally flow to the end from there anyway. I'm going to go ahead and run my compiler right now. Okay, still good. It's a miracle. And if you encounter a compiler issue, let us know in chat. All right, that's a relief. Okay, so let's go ahead and get numbers 2 and 3. And then we'll work on the macros part. So number 2. So we're going to use the conditional. So I don't know if you may or may not have noticed it, but I sort of I did the less fancy kind of conditional statements up here in the FizzBuzz section where I did compares and then branches. Down here on number 2, I'm going to use the conditional execution style. So I'm going to test to see if R8 is that's a comma is equal to 100, and then I'm going to do an if then block. So if it is equal to 100, then I'm going to move when it's equal to 100 1 back into R8. So that's all number 2 needs, is just check to see if we've reached 100. If we have, then use an if then block to restore it back to 1. And I used the 2 different styles of performing decision making because I thought that the branching style felt easier to work with for FizzBuzz, and the conditional style felt easier to reset the counter down here, so that's why I did it. and then call the delay macro. So I will just do that. Call the delay macro, which is a little bit like calling a function. At this point, it's going to feel exactly like calling a function. And then before we switch over to the macros file, let's just make sure that we're still compiling. All right. So compiles quick. Okay, macros time. So we're going to start building up the macros one at a time. The first one is delay. So what I'm going to do is I'm going to go steal the delay code from another lab and plug it in here. So I'm going to show my browser and just show you that that's what I'm doing. So I'm just going to go back to like lab 12. First part should have the delay code in it somewhere. Did it not? Where's the delay? Did this one not have? Oh no, that was the button. It doesn't have delay. Not lab 12, lab 11. Here's a delay. So I'm stealing the delay code, and then I'm going to plug it in, so if you didn't get it that way, it's fine. So delay, there's my delay macro. So I took the counter from another lab, the same thing, and then I kept the delay label, which notice has to be different from the macro name, and then the little loop part that counts down to simulate a delay. Okay, making sure you can see. So I'm just kind of trying to pace myself until I can see that since there's a delay between me talking and you seeing, that you get that stuff. And then I'll tell you, so you got to be careful and make sure you get this R9 loaded up with a value, because that's how the delay loop works, is it counts that R9 value down until it hits 0. But calling a macro, all that really does is it sort of pulls in that block of code to the moment when you listed the macro in main. But it is, for now, just think of it as calling a function. I'm going to line it up prettier, is all, just to kill time. So what I'm going to do, though, is I'm going to implement a macro, and I'm going to compile, increment a macro and compile, just to make sure that after each one, everything's still intact. Okay, so fizz. Turn on. Okay, so interestingly, in the fizz macro, it's telling me that I already have registers that I can manipulate. I'm going to go back and just see how that might work. Yes, that's that's pretty cool. So all I have to do here is literally what it's saying to do. Um, use OR to enable those bits, use OR to enable these bits, and I'm done. At least that's what the macro says I'm supposed to do, so that's what I'm going to do. Okay, so A5, A6, A7, A8, 1, 2, 3, 4, 9, 10, 11, 12, 13, 14, 15, 16. So I need, I should have done those as dashes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I need none of those. That's 2 to the third, 2 to the fourth, I don't need. 2 to the fifth, I do need. 2 to the sixth, 2 to the seventh, 2 to the eighth. So all I have to do here is alter R3 with a hex value. And that is 1 E15 minus 1 is 4, yeah, E0. So there's that one. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I don't need 2 to the 0th. 2 to the first. 2 squared is the one that I got to hit. So there's my OR value for R7. And you can check my hex values. So in theory, that's all I have to do. And this is a very sort of light touch way to start using macros. But if you think about registers being globals, then what the macros are really doing is they're just taking advantage of the fact that there are these global variables that can be altered. So in theory, that's all Fizz has to do. But I'm going to run the compiler again just to make sure that I haven't made any mistakes as I go. So do a macro, run the compiler, and just sort of keep working my way down. Okay, there's the Fizz part. Here's the Buzz part. A9. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So A9 is way up here. That's 2 to the 7th, 2 to the 8th, 2 to the 9th. So that one's pretty easy. Tells me to touch R3. Right here it does. So I'm just going to OR that hex value in there, which is 200. R5. 1, 2, 3, 4, 5, 6, 7, 8, 15, 16. R5. Okay, so 8, 9, and 10, so none of those. It's up to 2 to the 7th, so I need 2 to the 8th, 2 to the 9th, 2 to the 10th. $700. I'm looking at chat, so if you catch me making a mistake on a hex value, please let me know. The only one I want here is... Oh wait, PC3. I'm way off. PC2 to the 0 first. That's this one. PC3. 8, 9, 10, 9, PC2, 0, 1, 2, 4, 5, 6, 7, 8. Okay, I just had to go back and check all of my bit settings because I lost confidence there for a moment. R7 is simply going to be 8. So these patterns are all over the place, so need to be careful about that. But we're all working together, so if one of us makes a mistake, i.e. if I make a mistake, hopefully one of you guys will catch it and say something. There's Buzz, now Fizz Buzz. I don't actually know what this one's going to do at this point, by the way. we're going to have to find out. Now I think I have the idea of what this circuit does is off. Because on fizz, a whole bunch of lights come on. And on buzz, a whole bunch of lights come on. So we'll see. I guess we're going to see what happens. Okay, fizz buzz, so 16. I don't have anything until 2 to the 5th. That's 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th. That's 3 E 0. I've seen that value before. R5. Oh, I forgot to get the bit pattern. Let's see. I don't need anything until 2 to the 8th. So 2 to the 8th, 2 to the 9th, 2 to the 10th. So that is 700. And PC10. So I don't need any of those. 7th. So there's 2 to the 8th, 2 to the 9th, 2 to the 10th. This one is 400, I think. We won't know until we see it run. Hopefully the pacing is okay. Obviously you don't have to work out the bit pattern because I did, so hopefully that slows me down just a little bit. After every macro, I'm running the assembler step just to check for compiler errors, i.e. coding errors. I do not want to do this, but I'm going to do it. We have this code, so if you don't want to do this step, you can go grab this code from lab 11. But I'm going to go ahead and implement it. Oh, you know what? Let's leave this part blank and run the circuit. That's what I want to do. So when it invokes the value macro, nothing's going to happen, and I'm okay with that for now. Let's see if the fizz buzz starts, if it works. So here's what should. No, you won't be able to see it very well. So no, that doesn't make any sense. We won't be able to count 1, 2, fizz, 4, buzz. So we're gonna have to do this part. But again, you have it, so if you want, you can go copy and paste this. I'm going to do it manually. So I'm going to be testing bits in R8, test value in R8. So I'm going to have to test the individual bits in R8. So the first thing I'm going to do is I'm going to set up all the test parts. Hopefully that doesn't make it confusing, but I'm just going to march down the line. So that's the 2 to the 0th bit of R8, the 2 to the 1st bit of R8, the 2 squared bit of R8, the 2 cubed bit of R8, the 2 to the 4th bit of R8, the 2 to the 5th bit of R8, the 2 to the 6th bit of R8, and the 2 to the 7th bit of R8. Now I have to set up the logic, but there's me just going down R8. I'm looking at every bit to see which one of those is on right now because the value has it be on. Like when the counter first starts, the value of R8 is going to be 1, which means that this bit will be set. These all get an if-then not equal because bit level testing is the backward one. So I'm just going to go set all those IT blocks up. So now I have the IT blocks, and then I'm ready to do the code part. So this thing up here it's kind of backwards, but it tells me that A5 is the 2 to the 0. So A6 will be 2 to the first, 2 squared, 2 cubed. So if I wanted to map that, that's A5. This is A6. This is A7. This is A8. And I'm kind of sloppy about that. Hopefully everyone knows I'm talking about general purpose IOA pin. But at a point, it's just extra typing. So hopefully you all know what I'm talking about. What I'm referring to is the GPIO pins. This one's B8, B9, B10. Now I put those comments in there just to give you a reference point so you know what it is that I'm doing. So all of these are going to OR something on not equal. A values in R3, so all the A ones are going to be R3, and I'm talking to one person in particular who's probably not here right now, but will be watching this video later. You are not paying attention. So I am saying this for you. Those that I've highlighted are the R3 ones. The others are not R3 ones. Watch. Okay, A5. That is, I'm going to do these a little bit faster. 2 to the 4th, 2 to the 5th, so that's A5. A6, pretty easy. There's just one more over. That's 40. Still in the A's, so still on R3. This one is A7. Which is 80. A8 starting to get out there a little bit. So remember, R8 is the value that I'm seeing, which of the bits in that current value are set, and then R3 is what's connected on the circuit to an LED. So that is PA5, the LED that's wired to PA5, the LED that's wired to PA6, the LED that's wired to PA7. If you've been here sort of just consistently doing the class, I think I'm probably starting to wear you out on reminding you of these things. But if you haven't been consistently here, then you may be feeling a little bit lost, and so I'm doing my best to catch you up on months of doing nothing. Let's see, A8, so that is that, 2 to the 8th. 2 to the ninth, and then it's time to move on to the b's, but I still got one more a to do. That's the value needs to be manipulated. So that is 2 to the ninth. All right, now I'm in the b's. So again, sorry for the regulars. You long since know this, but I'm just going to keep calling attention to it until I can get the greatest amount of correctness achievable. So I'm in the b's, and the value that for the b bits is in R5. So I need to be ORing R5 if I want to make changes for the b bits. You don't have to line things up the way I'm doing. I just think it looks pretty this way. R5 now. And this is 8. Dang it, 8. That's that. Why not cheat and just make an adjustment? So I'm making an adjustment. People who don't pay attention, making an adjustment. I copied that to save myself some time, but I'm on B9, which is, that has to move over to 2 to the ninth, which makes that digit 2. And then one more, B10, so 2 to the 7th, 8th, 9th, 10th, 2 to the 10th, which makes that one 4. Okay. That's the same. We've done that code twice already, I think, at this point, so it was perfectly fine if you didn't want to watch me do that and to copy and paste. So sorry for chewing up time out of your life for something that most of you have seen a whole bunch of times at this point. That's all it does. That is all that it does. So I'm going to go compile, make sure I didn't screw anything up, which I did not do, so I'm very happy. It's time to power up and finish the rest of the recipe and see if it works. What you're going to see, by the way, is that's old code. That's someone's old counter code. So now I need to go finish the recipe. So we are on lab 13 this week. I've gotten a couple of questions from people about what's due this week. The deadlines haven't changed. If in doubt, just use the schedule online. So this week is homework 12 and lab 13. We did have a week where we let one go late, but we're now caught up, so we're not doing anything late anymore. Lab 13. So I just did the assemble step, so I'm going to do the elf step. Doing the elf step. Ah, dang it. It's going to be messy. Looking for errors here, so if you get an error, stop because something's wrong. Going to do the bin step. And then the flash step, at which point I want to see jolly good and then reset my board and see what it does. Okay, so now the big reveal. Once I hit refresh, what it should do is 1, 2, 3 is fizz, 4 is a value, 5 is buzz, 6 should be fizz because it's evenly divisible. So I'm going to write down what I am about to expect to have happen from 1 to 100. And sorry, I know it's taken time to do that, but from 1 to 100 should do 1, 2, that's fizz, 4, buzz, 6 is fizz, 7 is just the value, 8 is just the value, 9 is fizz. Let's just go 1 to 15 because I'm taking up, let's see, 9. 10 is buzz, 11 is just the value, 12 is fizz, 13 is just the value, 14 is just the value, and then 15 should be fizz buzz. That's the first one. So it's going to be in LEDs, of course, but binary value, whatever that macro just did is when fizz is going to pop. Value, whatever that macro does for buzz when it pops. You can't see any of that, can you? Oh no, I put it back. Okay, good. So just remember that this is coming out in LEDs. So fizz buzz, we'll see what it does. Okay, so now the big reveal. Because I'm going to reset. 1, 2, fizz, 3, buzz. It's going too fast. I have to slow it down because it's going too fast. But what, I don't know if you can see it, and let me reset. So fizz does a color on the LED and it lights up half the bank. And then buzz does a different color of LED and lights up the other half. And then fizz buzz does the third color and then flashes all of them. So to fizz, buzz. Here comes fizz buzz. So hopefully you saw that. So there is, and you can't see it, but I'll reset again. So 1, 2, fizz, buzz. Coming up on fizz buzz here. This will be the third. There, that was the third color. So there's fizz. I'm going to slow it down just to study it a little bit. So the way to slow this down is to go to the macro now. We have a delay macro. And I'm just going to make this value bigger. My guess is if I make this, if I make that even a 2, I think that scales up pretty big. So I just change the 1 to a 2 there in the counter for the delay loop because I want to slow this down. So now I'm going to go back and I'm going to have to do the whole process over again. So go back to the assembler step, the elf step, the bin step, the flash step, jolly good. Going to reset, see if it's a little bit slower. 1, 2, fizz, 4, buzz, 7, or I lose count. 1, 2, 3's fizz, 4, 5's buzz, 6's fizz, 7, 8, 9's fizz, 10's buzz, 11, 12 is fizz, 13, 14, 15 fizz buzz, 16, 17, 18 was fizz, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30's fizz buzz. So hopefully you're getting some kind of result as well. In my excitement, I bent this one. I gave this one a pretty hard bend. So there is assembly fizz buzz with LED display, which I'm pretty dang excited about. I think that's a lot of fun. Pardon. Okay, thanks for sticking me out longer than normal. I'm just going to sit here for a few minutes and answer questions to help you clean up, and I can scroll the code around or whatever it is that you need. I promise I'll stop preaching at the... Oh, outstanding. All right, so Vince's works. Yeah, it's got to be a code thing. Make sure you press the reset button as well, but probably you already did that, Jack. So Yes, somewhere the code's unhappy. All my lights just turn on and not doing the fizz buzz. Yeah, something isn't happy. If you can, well, I'll wait for a few minutes, but you may just sort of go back and hit the video once I stop broadcasting and kind of just skip your way around and double check your code. But if you can find something in the next couple minutes, I'm happy to um, help you fix it. Anybody else got a thing that works? I also hope that some of you are thinking, oh, these macros, thank goodness. Okay. Yeah, Daisuke, don't worry about that. That's um, like I was saying at the start, the plugin was getting that syntax highlighting wrong. So with that include, so you can try this and see if it cleans up. But you have to remember to take that off before you compile. The other thing to do is to check your atom down here at the bottom right and see if it says that there's an update. You should have one. Vince got one and I got one, and for both of us that fixed the syntax highlighting problem. But but if your syntax highlighting is messed up and you can't get it to cooperate, temporarily comment out macros, and then you got to make yourself remember to go comment it back in. But if you forget, you'll get a compiler error. So um, that's really the only kind of fix if you don't get the plugin update is to comment the macro out. Thanks, Vince. You have a good weekend too. Appreciate it. That might be difficult to the um, In theory, you shouldn't have. There's not really a way to get a mistake on the second step unless there was a mistake on the first step. Really, so there had to be an error dice K on the first step, um, because um, the only way to get an error on the second step is to have an error on the first step. I'm pretty sure. So you need to rerun the assembler step and then look at your error output, and let's see what that is. Okay, so I'm going to check out, rest my voice for a bit before I have my next class. So um, if you're just utterly stuck, uh, please email me and send your code, or at least send error outputs or something specific that I can look at. Is usually easier for me to answer your question if you give me more details. So um, keep that in mind. And you can also post to Discord, and it's possible that me or another student will answer that. Um, and then don't forget, the video will be available, so you might start just by sort of um, reviewing the video again and see if you can figure out uh, where you have a mistake. Okay, so I'm going to check out. Everybody have a good weekend. I will be back here on Tuesday. We're finally sort of getting to the very short end of the semester, so just a few more weeks to go.